sir, it was really easy to find the slope of just a straight line, but how would you find the slope of a curved line?
That's a good question. Slope of a curved line. Do you know anything about tangents?
Yeah, a tangent is like a line that touches the surface of a circle at one point.
Yeah. Well, that is a definition of tangent which we kind of know, right?
Yeah, but it's really difficult to find the slope of a curve.
That is true.
Yeah.
That is true. And tangent definition doesn't really, this definition of tangent doesn't really fit into the curve definition.
Right.
What you're saying is right. If there is a circle, then a tangent will touch only at one point. Because if it goes from somewhere else, it will touch at 2 points. Or if it is far away, it won't even touch, right? But in a curve, well, let's see, like curve like this, right? Any irregular curve, not like a circle, right? So what happens? If I draw a tangent here, then that tangent may touch the curve at other points also. You see, it is a tangent here. It touches this curve at this point, 1 point. But if I extend it, it may touch the curve at the other points also. So that restriction doesn't really apply to different types of curves. And even think like this. If I draw my line like this, it is no more a tangent, but it touches the curve only at 1 point, right? So either way, it doesn't work, right? It was perfectly fine till you did circles and all, but now when we are doing polynomials and so many different equations for grade 12, its definition changes. And now we say tangents basically, let me also introduce you to the concept of tangent, and then we'll come back to tangent. So in a curve, as you can see, we can have a line like this. Let's say we want to find tangent at this particular point. Then what we do is we take a point somewhere far away, and then if we join this point, it is called a chord, like, and we call it a secant here, right? Secant is touching at 2 points. Now as I bring this point closer and closer, then you see. Now here also it's touching 2 points, but the second point is closer to the first point. As I bring this point very, very close to my actual point, where I need to find the tangent, it becomes a perfect slope there, touching only at 1 point. And there, the slope of this just means the slope of the tangent, and this is the tangent, right? So slope, as you did in lines, you said it was so easy in lines, right?
Yeah.
So when you have a slope, this line, then drop a perpendicular and make your right angle triangle. Once you have made one, then rise over run is your slope. And just like a straight line, so it boils down to the same thing. So if you are good at finding slopes for straight lines, you can always do for tangents for any curve also. Right? But just remember how to draw that tangent on a curve. The idea is take a point and take another point close by. Bring the other point so close that when you touch the two, then it seems as if curve is being touched only at 1 point. Then it changes, that line becomes a tangent to the curve at that point. Now extend the line and make your right angle triangle as you did for lines, right? You rise over run, and there you go. That's the slope of your tangent, right? Tan theta.
Wow, that makes it really easy.
That's so simple. Correct? So it gives you tan theta, right? So you know what tan theta is? And how did tan theta came? We'll do that in the next video, okay? Okay, see you. Thank you.